Hi everybody. I have received a few requests from my students to record a demonstration about how to implement DataGuard in Oracle RAC environment. In this demonstration, I'm gonna illustrate how to create an Oracle 12c R2 physical standby database from a primary RAC database. As you will see in this demonstration, there isn't actually much difference between creating a DataGuard in a single instance database and a RAC database. However, it's very important to understand the difference between implementing DataGuard in a RAC database and a single instance database. And this is the main objective of this tutorial, to realize the difference between implementing a DataGuard in Oracle RAC and in Oracle single instance database. This is a high-level description about the environment that I am working on. The database that I have on the primary side is called RAC. It basically contains two nodes, RAC1 and RAC2, and they both use ASM as shared storage. In the standby side, I also have a RAC database, and it also contains of two instances. The instance names on the standby side are std-rac1 and std-rac2. Again, they use ASM as shared storage. As is the case when implementing the DataGuard in a single instance database, you have to have the DB name the same in both the primary side and the standby side. In this case, the DB name in the standby side will be RAC. But the DB unique name is different in the standby database, and it is std-rac in the standby database in my environment. This demonstration is not about DataGuard. It is not about RAC administration. I assume from the audience that they already know the basics about Oracle RAC and DataGuard. And I also assume from the audience that they have the basics of Linux operating system. This demonstration is based on a Linux operating system, not Windows operating system. As I said earlier, the main objective of this tutorial is to demonstrate the difference between implementing DataGuard in a non-cluster single instance database and RAC database. This demonstration assumes that we already have the virtual machines created using Oracle VirtualBox software. It also assumes that we have 4 virtual machines. The first 2 machines are the nodes of the primary database, and the other pair is the 2 nodes of the standby database. The first 2 machines are the cluster of the primary database, and it has an Oracle 12c R2 RAC database installed in it. The other 2 machines are the cluster of the standby database. It has the same software version, Oracle 12c R2 Grid Infrastructure and Oracle 12c R2 database software installed in this cluster. Both the primary database and the standby database use ASM as shared storage. In the standby database, you have only ASM configured in this cluster. At this stage, you have only ASM configured in the standby cluster. Later in this demonstration, you will create the standby database in this cluster. This diagram is a high-level description of the primary database that I am using in this demonstration. As you see, the instance names are RAC1 and RAC2. The host names of the nodes are SRV1 and SRV2. The scan name used for both nodes is SRV scan. Each node has a local storage of 100 GB, and they use a shared ASM with 3 disk groups in it: CRS, Data, and FRA. On the standby side, we have also 2 nodes, std-rac1 and std-rac2. The host name of the nodes are SRVA and SRVB. They are configured to use the scan name srv scan2. Again, each node has its own local storage, and they both use ASM as shared storage. ASM has the same disk group names that are used in the primary database: CRS, data, and FRA. In this tutorial, I am using the following software products: PuTTY, Oracle VirtualBox, Oracle Grid Infrastructure, and Oracle Database. I'm pretty sure you are aware about all of them. Because you need 4 virtual machines to implement this demonstration, unfortunately, you need high-specs hardware to implement this demonstration. Either you need to have 2 physical PCs with 16 GB memory installed in it and 280 GB free disk space in each PC, or you need 1 single physical PC with 32 GB memory installed in it and half terabyte free disk space in the PC. I understand that this is too much for some people, but this is the only way to implement this demonstration. The operating system that I use to do this demonstration is Oracle Linux 6.7 64-bit. This demonstration is building up a data guard configuration with the following specifications. The protection mode is maximum performance, the fast start failover is disabled, the management interface is SQL Plus utility, and the standby database type will be physical standby. This demonstration will not cover the steps to perform the following: creating virtual machines from scratch, installing Oracle 12CR2 grid infrastructure and database software, and creating Oracle RAC database in the primary cluster. As I said earlier, this demonstration assumes that you are already aware about doing those tasks. Before getting into the practical side of this demonstration, let's talk about what are basically the major difference between implementing data guard in RAC and in non-cluster single instance database. First, when you use the command duplicate database for standby in RMAN utility, only a single instance RAC database is created. When you issue this command, you have to specify 2 important RAC-related parameters. They are instance number and instance name. Those parameters specify the instance number and the instance name of the standby instance in the standby system side. After that, you have to manually set those parameters for the other instance in the standby database. And finally, you have to add the created database in the clusterware OCR. Another point you have to take into your consideration: if you have a RAC primary database, it is not mandatory to have a RAC standby database. The standby database could be a RAC database or a non-cluster single database. Another considerations that you have to be aware about is that the redo-log files in the standby redo-log must reside in a location that is accessible by all the standby database instances. Every standby database instance must be configured to archive the standby redo-log to the same location. This tutorial suggests creating them in the FRA disk group in ASM. Finally, if OMF is not configured, log archive format must be set. And when you do that, you must configure the parameter $T to uniquely identify the archived redo-log files for each instance. If you don't do that, the redo-log files created by the instance could be overwritten by every instance. This is a high level of the procedure steps of this demonstration. Basically, they are the same steps that you follow when you implement data guard with a single instance database. When I go through the details of implementing this procedure, you will realize the little difference between implementing this procedure in a RAC database and single instance database. As is the case when you implement any data guard configuration, you start with preparing the primary database. Then you prepare the standby system. After that, you create the physical standby database, and finally you test and monitor the standby database. Let's get started with the demonstration. Before starting with this demonstration, I'd like to point out that I will make this document available for download. If you have the required hardware, I hope this document will help you to implement your own implementation of this tutorial. In the first step of this demonstration, I would like to make sure that every node in my configuration is able to access each other node. As you can see here, I have 4 machines running simultaneously. SRV1, SRV2, those are the nodes of the primary database. SRVA and SRVB, those are the nodes of the standby database. In the first step, I would like to make sure that every node can see all the other nodes in the network. So for every node, I'm going to ping the public host name and the virtual host name and the scan name of every database. I am executing the ping commands in the first node of the primary cluster. This is the first node in the standby cluster. I am going to execute the same ping commands. The virtual host names are being seen by every node. Now let's ping the scan names. In the second step, I'm going to verify that the cluster where services are running in the standby cluster. All the services are online in the standby cluster. Then I will verify that the required clusterware resources are all online. All the required resources are online in all the standby nodes. In the standby cluster, make sure that all the necessary applications are running in all the cluster nodes. I will go now through the steps to prepare the primary database. First, I will make sure that the archiving mode in the primary database is enabled. As you know, you must enable the archiving mode in the primary database to configure the data guard. The archiving mode is already enabled in my case. If it is not enabled, you must enable the archiving log mode before you proceed with the procedure. The document is demonstrating the steps that you should follow to enable the archiving log mode in your database. In the next step, I will enable the forced logging option in the database. This option must be enabled for any primary database in a data guard configuration. The forced logging option is already enabled in my primary database. As you know, when you set up a data guard configuration, you must create standby redo log files in the primary database as well as in the standby database. You have to determine the number of the required standby redo log files that should be created in the database. The formula that you should use to determine this number is demonstrated in the document. You have to obtain the maximum number of the redo log files in each database plus 1. Then multiply the result with the number of threads. The first select statement in the document will retrieve the redo log groups in the database. I have 4 redo log group in my database. Each one has size of 50 megabyte. The second select statement retrieves the number of threads in my database. In a RAC database, typically you will have a thread for each node. In my case, I have 2 threads, thread number 1 for RAC 1 and thread number 2 for RAC 2. So the conclusion is I have to create 10 standby redo log files in every database in my data guard configuration. In the next step, I will execute the commands as shown in the document to create 10 standby redo log files in the database. In normal operation, those files will not be used by the primary database. They will be used after switchover or failover operations. I have created 10 standby redo log files per thread per instance. We've got 2 threads and 2 instances. So we end up with having 40 standby redo log files created in the database. In the primary database cluster, configure the tnsnames.ora file in all the database nodes, srv1 and srv2. Bear in mind that you shouldn't copy the tnsnames.ora file settings from the PDF tutorial document. Copy them from the attached tnsnames.ora file or write them straight away into the file. Observe that the std-rac setting is using the public host name of the standby node, not the scan name or even the VIB name. Why is that? Remember, as I said earlier, when you issue the rman duplicate command, rman creates a single standby instance in a single standby node. So you want to make sure that rman is connecting to that specific node, not to any other node in the cluster. That's why we use the public host name of a specific node from the standby cluster. And that node is the node from which we are going to issue the duplicate command. rack setting is already there in my file, so I'm going to add the std rack settings only. Now I will add the same settings in SRV2 machine. You need to configure the tnsnames.ora file in the standby nodes as well. But in the node from where you will invoke rman, you should add the option UR equal to A in the standby connection descriptor, as shown in the tutorial document code example. The rack setting is not configured in the file, so I'm going to add it into the file. You need to copy the settings dedicated to the SRVA machine. Again, you need to configure the tnsnames.ora file in the remaining nodes of the standby cluster. Test the connection configuration in all the machines. In the primary database, set the initialization parameters required by the DataGuard configuration. Because we're working on a RAC database, I should use the SID option in the alter system statement to apply the changes on all the database instances. We have the same disk group names in the standby cluster as the group names in the primary cluster. That's why we don't need to configure those parameters, dp file name convert or pdp file name convert. You need to take note of those directories because you should create them later in the standby nodes. Enable the flashback database. This isn't required by the data guard, but it is highly recommended. Set the control file record keep time parameter to 30. This parameter controls the number of days in which the control file records should be retained. It is already set to 30 in my case. In all nodes, if SQLnet.ora file is not configured, create it and add the settings as shown in the tutorial document in it. In my case, the file is already configured in all the nodes. After preparing the primary database, it's time to prepare the standby system. On the standby server SRVA, create the directories pointed by the parameters. I have directories to be created in the ASM and directories to be created in the file system. Any directory that's being used by the database should be created. In SRVA, which is the first standby node, as Oracle user, create a P file named as init.sid.ora in the default directory. Enter in it just one parameter, that is the db_name. This is the only parameter needed to initially create the standby instance. Remember, this parameter is assigned the database name, not the instance name. The full SP file will be later created by the rman utility. In SRV1, copy the password file from the primary database system to the standby nodes SRVA and SRVP. As the password file is saved in the ASM, I'm going to use the ASMCMD utility to take a copy of the password file. The code to do that is demonstrated in the tutorial document. In SRVA, create a static entry in the local listener to the local standby database instance. Do not copy the code from the PDF file. Copy it from the attached file or type it straight away into the file. After adding the static registration setting, I need to restart the listener. Everything is now ready to start creating the standby database. Before starting the new standby instance, I recommend opening a monitoring session to monitor the alert log of the primary database. Its contents could be so helpful for you to troubleshoot any error you may face. You can also monitor the alert log generated by the standby instance. But of course, you cannot do it now. You can do it only after you start the standby instance. Let's now start up the standby instance. I will use the P file that I created earlier. The next step is the most important step in this tutorial. I will invoke the duplicate command in an RMAN session to create the standby database instance in the standby node. Please be aware that if the duplicate command fails for any reason, after it shuts down the auxiliary instance, you must shut down, then start up the standby instance again. You should also drop the created SP file before you can run the duplicate command again. Observe the two parameters in the duplicate command, instance name and instance number. Those parameters are required in the duplicate command when you want to create a standby instance for a data guard configuration. Observe also that the instance name is the same as the DB unique name, but with the trailing number added to it. Those errors indicate that RMAN is looking for the SP file in a location different from its actual location. Frankly, I don't know the root cause of this error, but the obvious workaround is to make copy of the SP file in the DBS directory. And that's what I'm going to do right now. After the duplicate command finishes, I will verify the instance is running fine. The standby redo-log files are multiplexed. In the next step, I will remove the multiplexed files. Remove the multiplexed copy of each SRL group on the standby instance. As you see, the SRL files are distributed on two disk groups, Data and FRA. I will keep the FRA files and remove the files in the Data disk group. This select statement generates the commands that you should execute to drop the SRL files from the Data disk group. I just need to execute the output of the select statement. I will just paste the output in a notepad file. I should have 20 statements to execute. This error means the standby redo-log on concern is being used by the transport service. To drop it, On the primary database, switch the current log file. When you do that, the current standby redo log file will also switch to the next SRL group, allowing you to drop the SRL file that couldn't be dropped. I will just take a copy of the statement that failed. Those are the two statements that failed in my case. On the primary database, I will switch the current log file. I will run the statement twice. I will do the same on the second primary database node. I will try now to execute the failed statements again. Remember, I should execute them on the standby database. The remaining multiplexed SRL files have been successfully removed. Verify the SRL group multiplexed members were successfully removed. We have now only 20 SRL files, which is a fair indication that all the multiplexed files were successfully removed. And they are all in the FRA disk group. At the moment, most of the parameters in the standby instance have the same values as in the primary database. I should now set the data guard related initialization parameters for the standby database std_rac. Again, don't forget to use the SID option to make the changes applicable to all the instances. I have now the standby instance up and running in SRVA machine, but it isn't recognized by the clusterware. At this step, I will add the standby database resource in the clusterware OCR. I use the srvctl add database command to add the database, and srvctl add instance command to add the instances. At this stage, the SP file is in the file system. Let's relocate it to the ASM. ASM is much better because it is shared by all the instances. First, I will create a copy of the initialization parameter file in ASM. As you can see, the SP file is located locally in the file system. Then I will modify the P file parameter to make it pointing to the new location of the SP file in the ASM. This should be done in all the cluster nodes. Finally, I need to update the OCR with the new SP file location. Restart the standby instance. Please observe over here, I am restarting the instance, not the entire standby database. The second standby database instance is not ready yet. I should set its instance name and instance number before I can start it up. I will do that soon. For now, I will just restart the first instance. Connect to the database and verify that the SP file parameter has been successfully set. Set the correct instance name and instance number for the standby instances in SP file. The parameters have been correctly set. So now I can start the second instance in the standby database. Start the apply process in the standby database. check out the data guard configuration in each database. We have now a fully functional standby rack database synchronized with the primary database. Let's do some checking on the Redo transport services. On the standby database, list the SRL files. The maximum sequence number is 1720. On the primary database, switch the log file. On the standby database, list the SRL files again. The current SRL file sequence number has been incremented. In the standby database, run the query as shown in the tutorial document to retrieve the data guard active apply rate and average apply rate statistics. In the standby database, retrieve the transport lag and the apply lag. Transport lag represents the data that will be lost in case of a disaster. In the standby system, check the state of the standby database instance resources. The states of the standby database instances are intermediate. Those are the steps that you normally do after you build up a standby database. First, you configure the archive deletion policy in RMAN. This is useful to disallow deleting any archived Redolog files until they are shipped to the standby instances. You can run the command from one node of the database cluster. You don't have to run it from every node. Although the standby instance was a copy of the primary database, the database flashback isn't enabled in it by default. On the standby database, enable the flashback database option. Let's test the data guard functionality. On the primary database, create a new testing table space. Verify that the table space has been successfully and automatically created in the standby database. Connect to the standby database and check out the table space. In real-life scenario, after you create a physical standby database, you may consider implementing the following tasks. Configure the data guard broker, consider the need to upgrade the protection mode, and put on a mechanism to purge the archived read logs on the standby. There isn't much difference between configuring the data guard in non-cluster single instance databases and RAC databases. The most important differences are the following. You need to specify the parameters instance name and instance number for the standby database. In the standby database, it is recommended to copy the SP file to a shared storage that is accessible by all the instances, like ASM. And finally, you need to register the standby database instances and the new location of the SP file in the clusterware OCR. Till seeing you in another tutorial, thank you very much.